Hello and welcome to the seventh video in our lecture on weaknesses of the public key crypto systems. So notice that we're talking about the second main problem, which is the public key distribution problem. And in a previous video, we explained how we solve this problem using public key certificates. So I'm going to put up a picture which I grabbed from a very good video that I found online. So before I show you the picture, you might want to look up this guy's name on YouTube and either Google these two topics, Introduction to Digital Certificates and Digital Certificates Chain of Trust, or you can just type in those two URL within YouTube. But these two 15-minute videos are very, personally, I think the best explanation I've seen about digital certificates and certificate authorities, including intermediate soft certificate authorities that we're going to mention in this video. So here is a screenshot I captured from that video. So let's say you want to do a secure connection with Amazon, and Amazon will send you a certificate. Let's discuss how Amazon first obtains this certificate and then how you use it to trust their public key. So in this case, let's say the user is Amazon. Amazon, when they set up their business, they generated two keys, a private key and a public key, and they wanted to get a certificate for their public key. So they put together a package of information called a certificate request that contained both their public key and their identifying information, the name of their business, the address, etc., etc. They put that into that request that was then sent to the certification authority they chose. So again, the user is Amazon. They're trying to get a certificate. They make a request to the CA. The CA will verify that this identification information is actually correct and that they're actually getting a request from Amazon, and they will build a certificate for that user, in this case, Amazon. And so what we're going to discuss is in this video is how that certificate is built. Remember, the certificate contains two pieces of information, namely the public key of Amazon, of the user in this case, and then the Amazon's identification information. And most importantly, the certificate will bind this public key to this owner by using a signature that the CA is willing to attach to that certificate and saying, yes, I check that this public key is actually owned by this owner. And this is the certificate that will be returned to Amazon, and that will be the certificate for the Amazon web server. And so now every time you're going to Amazon, the certificate you receive from Amazon is this certificate. Okay, so that's the general principle. Now let's look into both the process that the CA uses to generate the certificate and what the certificate contains. So let me go back to my video here. So here we have, so Bob is in this picture, which I got from a textbook, is the equivalent of Amazon. So Amazon or Bob send its identification information and its public key. And the CA then in this process is going to add its own information, the name of the company and its credentials. This together will be, this white part is the unsigned certificate. The CA is now going to sign this certificate. So it's going to take all of this information, it's going to hash it, okay, to get a hash code of the unsigned certificate, and then it will encrypt this hash code using its own private key. This is the private key of the CA. And remember, everybody trusts that certificate authority. So this signed or encrypted hash code is going to be added to the unsigned certificate to together make up the signed certificate. So this is the signed certificate that we've been talking about. Public key certificate that contains the public key of the business, in this case Amazon, and that will prove to whoever received that certificate that this key indeed belongs to Amazon. So let me show you in my browser here. I'm making an HTTPS connection to Amazon. This lock icon says that I'm doing a secure connection. So if I click on this lock, I see a bunch of information about this connection. In particular, I see a certificate option, which I'm going to select. And so notice now I have a certificate and I click on details. It shows me that the subject name, that's the name of the client that the certificate was issued to, is Amazon.com. Its location is Seattle, and so on and so forth. So this is the identification information of the subject, meaning the owner of the public key, or the client of the CA. And here is the information about the CA. That is in this case, GGCert is the company that serves as the CA. And in fact, the name of the certificate authority in this case is DigiCert Global CA G2. And that's indeed what it shows right here. The Amazon.com certificate was issued by this CA. So let's see if I can find this DigiCert Global CA G2 in my browser. So my browser has a so-called keychain that contains all of the certificates that it actually trusts. So if I go to my keychain here, I got a list of all of my certificates. I have quite a few of them. And again, these are built into my browser. So when you decide to use a browser, that means you're agreeing to using all of the certificates that are issued by the CAs that this browser trusts. And the built-in CAs in my browser include a bunch of DigiCert CAs. So we have some root CAs and some other CAs that are all owned and managed by DigiCert. Another common one is GeoTrust, and you got Entrust, and you have GoDaddy down here. GlobalSign is a common one, and GoDaddy, and so on. But the one from Amazon was issued by DigiCert, so let me look at this one. Now remember that the CA that issued this certificate was DigiCert Global CAG2. And notice that CA is not trusted by my browser. It's not listed here in the keychain. So that's a problem, or it would be a problem, unless I realize that this CA is actually what's called an intermediate CA. And itself, it was trusted by this root CA called DigiCert Global Root G2. So what you need to realize is that there are quite a few CAs around, and some of them are called root CAs that the browsers actually trust. And then you have these other CAs called intermediate CAs that are trusted by the root CAs. That the root CAs are delegating their trust to some intermediate CAs. And notice, even though this intermediate CA is not trusted by my browser is going to trust this root CA called DigiCert Global Root G2. So if I go back to my keychain, I see this root CA right here. So what happens then is that this certificate was signed by this intermediate CA, which in turn was trusted by the root CA. And this is called the chain of trust. And that's the topic of the second video that I showed you on YouTube earlier. So if you want to understand this in a little bit more detail, make sure you check out that video. It's really cool. But the bottom line now is that because my browser trusts this root CA, and because this root CA trusts this intermediate CA, and because this intermediate CA signed off on the certificate from Amazon, when I do this connection, I am now implicitly trusting that I'm actually communicating with the Amazon server. So let's go back to the slide and see how this process of verification is done on the browser side. So on the browser side, the browser receives the certificate. First, it will take the unsigned certificate, the white part, and hash it using the same hashing function that's agreed upon in that protocol, will get a hash code, and then it will use the public key of the certification authority, the CA. It's a public key that is contained within the browser. Since the browser trusts that CA, it will decrypt the encrypted or signed certificate part of the certificate and get the decrypted hash code. If the hash code that was obtained by decryption of the signed certificate matches the hash code obtained by the browser when it hashed the unsigned certificate, then it knows that this certificate was not tampered with and is the original certificate that guarantees that this public key was Amazon's public key, at least if you trust the CA. So that's a slightly detailed information about how this certification process works. And this is how we solve the public key distribution problem using public key certificates. Let me just wrap up this video by putting up again these two videos. In particular, if you want to know more about the chain of trust and the intermediate CAs, you definitely want to watch this 15-minute video posted on YouTube by this user, which is extremely good.